Hi, this is Paula Bernier with TMC. We're here in Huntsville, Alabama at ADTRAN headquarters, and I'm getting ready to talk to Steve Shipley. He's the Director of Product Qualification. Let's go take a look. Hi, Steve. How are you?
Hey, how are you?
Good. Can you show us a bit about what's going on right here?
Sure. So we are in the Reliability and Component Engineering Lab here at ADTRAN, and what this lab concentrates on is environmental testing. So if we make a claim that a product works from -40 to +70°C at 95% humidity, this is the lab all that testing occurs in. What you see here is just an example of one of the tools we use. This is a thermal imaging camera, and we use this early on in the design and really throughout the entire design process, and we also use it on field failures. What this shows you is the case temperature of components on this particular board. This happens to be one of our HDSL modules. In the old days, we used to use thermocouples on this, but as you can see here, this gives us the exact case temperature on really every component on the board. You can see that this particular component right here is sitting about 65°C case temperature. So early in the design, we can take this to the design labs, give them an image of their board initially, and then work with them on proper thermal design, like putting in a heat sink in the right place, moving components around, maybe changing the ground plane thickness. So it's been a really great tool for us.
What else do you have to show us?
Let's go over here and we'll look at some of our component analysis capabilities here. So this is Kyle Brown. And Kyle is one of the technicians here and does a lot of our component analysis for us. And he's got an example here of just some of the component analysis that we do.
Kyle, what can you tell us about this?
Well, what I have here are two decapsulated integrated circuits. And this decapsulation capability gives us the ability to take a failed integrated circuit, open up the epoxy, and actually examine the die surface within. And I'll show you here, we've got one good sample and one bad sample. This is actually a normal integrated circuit. Okay, as you see, it's clean, there's no damage. But when you go over here to this sample, you see severe electrical overstress at the top of the die surface. And this is an indication of most likely extremely high voltage. And as you can see by the discoloration on the die here, there's also some localized heating caused most likely by current. And then we can go up here and you can actually see the wire is melted in this direction, so we know that the current traveled in that direction. So we have very good evidence here that this part was zapped by either a transient voltage or some high voltage spike of some sort.
And how do you use that kind of information?
Well, we use this in component failure analysis. If we have a product in the field that fails and they send it back to ADTRAN and they analyze the board and say, we think this is the part that failed, we can then prove or disprove that theory using these type methods.
Thank you very much, Kyle. What else do you have to show us, Steve?
So let's take a trip around the corner here. This is actually one of our large-scale chambers here that we do a lot of our cabinet testing in. So this chamber here, we've got the ability to do solar loading in it. And one of the things that always comes up with our products, and you'll see some of these here in just a minute, is what happens if we put them in the middle of the desert, getting hit by 140-degree temperatures with the sun pounded down on them. In this chamber here, we'll put thermocouples on our products in the chamber in the worst case operating environments, and then measure what the case temperatures are on our products to make sure that we don't get above any specified value. And usually at the same time, we're monitoring data flow on those to make sure nothing goes awry.
And do you share this data with your customers?
Absolutely. That's one of the things that our customers have taken advantage of over the years. We can share this data with them, and we'll also share our product qualification test reports with them. That'll be the lab that I'll show you here in just a little while.
Great. What else do we have to see?
All right.
Now, Steve, what do we have going on over here other than CNN?
Well, so triple play in the last 3 years here at ADTRAN has become very, very important, and we've really incorporated video, data, and voice testing across all labs here at ADTRAN. Video is very unforgiving of any kind of anomalies, and as a result of this, one of the things that we have going right now in the chamber, we have our ONTs. going through temperature testing. So in this particular case, this ONT will be run from about minus 40 to probably about 70 C, which is 158 degrees Fahrenheit. What we're doing here is we have the ability to inject calls, which you see right here, bulk calls, live data coming from our satellite feed, at the same time that we're hitting it with data coming in from our data generator. What we look for over temperature is for any pixelization in the video. In a lot of cases, while you're temperature testing, you can get an idea of what the failure may be by the place in the temperature cycle that it fails. So for example, if it's going hot and we see a blip on video or a lapse in data, that may be indicative of a cracked solder joint. And as the temperature increases, the solder joint expands, spreads apart. As it goes cold, it pulls it back together again. So as it spreads apart, data or video stops. So in a lot of cases, we're going to be able to tell what the failure mode may be just by the indications that we're getting outside of the chamber.
Okay, what else do you have to show us?
All right. So one of the things that I wanted to show you was just, we have a silicon development team here at ADTRAN that over the years has allowed us to produce consistently cheaper, more reliable products, and that's really one of the keys to our success. So this was the first gen HDSL HTUR that we built. You can see it's a two-board design and multiple components on it. So that was one of the first gen units that we ever built. This is one of our later generations. So it's down to a single board, and the number of components has been greatly reduced. So our silicon development team has really taken what you would see, well, like in this area here on this board, and combine that into a single piece of silicon.
And how does that save service providers and other companies that own networks in savings?
Well, so the per unit cost is drastically reduced as a result of this kind of technology. The other thing that I wanted to mention is the silicon development team, it's not just oriented towards HDSL. It's really key to all of our new developments. Our IP business gateways are all included in on that, along with our TA5000 products and our OSP DSLAMs. This is just a very good example of how this team can really make a product less expensive on a per unit basis while making the product more reliable. So that's a very good combination.
And also making it smaller, I would assume, would mean less heating and cooling, less real estate in the data center or the CO?
Exactly. So the footprint of that is obviously a lot less than the footprint of this, so it actually conserves space in the CO.
Right. And how does all this that you're doing in the lab relate to the green movement, to use less energy, to have things be more environmentally friendly?
Well, so we have requirements that we've had to reduce the power consumption on products here at ADTRAN. In this lab and other labs, we're paying particular attention to that now from a green standpoint. We have requirements from a RoHS standpoint that have basically required all companies to reduce the amount of lead that's used in our manufacturing process. So that's just two examples of what we do from a green standpoint.
Great. What else do you have to show us? So now we're in the product qualification lab at ADTRAN. Can you tell us what we're seeing here?
Sure. Product qualification, this lab concentrates on large-scale applications testing. So this is really the last stage of test in the development process. We'll see a DVT lab later in the day. That's the first stage of test in our process. But what we see here is we really concentrate on large-scale data, voice, and video testing. And I'll show you some of the traffic generators that we use. What you see here is one of our video test labs. And what we have is a TA5000 being driven, live video being fed into the GigE port on that 5000, and it's being pumped out to this ONT, which is our product that would go on the side of someone's house. And out of this ONT, we're going to our set-top boxes. And out of our set-top boxes, we go to our live video that you see here. So one of the things that, just as a quick example, that we always look for during video testing on our products is to make sure that video stays pristine after it comes through our products. So one of the things that we do here, this is our satellite feed, live satellite feed that we have here. We always compare reference video at each point in the network. So this is reference video directly off the satellite feed. What we do is compare the quality of that video to the quality of the video coming out of our product to ensure that no degradation occurred as a result of the video flowing through our products. In this case, a TA5000. The other thing that we do a lot of is we make sure that if the TA5000 becomes congested, the network uplink becomes congested with data, that data throttles back and video gets the priority that it should. So you always want video and voice to get the priority in these networks. And thus the name triple play comes in.
Right, customer experience and quality of service are such a big thing. So the lab addresses not just the performance and of individual components and how things work under different environmental considerations, but also the end user experience with the application.
That's right. We found that people are a lot more forgiving of a slow internet connection than they are desperate housewives pixelating on them.
Right. And so what about interoperability? Do you have other vendors' equipments in the lab that you're doing interoperability with?
Absolutely. So that's part of this lab is large scale. So from a video perspective on the TA5000 and all of our products, we're not just selling our products, we're selling a solution. We're selling a system solution. So we have multiple different types of middleware, for example. We have Microsoft Media Room. We have two other vendors of middleware. Then we have the ability to drive traffic over all those with some of our traffic generators that I can show you here in just a minute if you'd like.
Okay, that would be great. Okay. So we have racks and racks of equipment here, but I'm not sure what it all is. What are we looking at?
So this is one of our main solutions in our TA5000 product line. This solution here is our Ethernet over copper, Ethernet over TDM solution. And the reason I wanted to show you this is to just give you an idea of the scale of testing that goes into our TA5000 product line. So these are all what we call NCTEs. So these are T1 versions. We have HDSL versions, SHDSL versions right here. What this allows a service provider to do is bond a certain type of copper into an Ethernet service delivery to a customer. So these would go at the customer sites. But the great thing about this solution is the fact that as a customer's business grows, they can call the service provider and simply request another 1.5 meg. And then the service provider can bond any loop to any other loop out of our shelf and supply them with an additional 1.5 meg.
Without a truck roll, you mean?
Without a truck roll. So it's a great solution for us. But the theory behind all this is that throughout the lab really is that we have to run data and video and voice over everything simultaneously. So you'll notice that the gray wires, and this could be through our Ethernet over copper, Ethernet over TDM solution, or our business solutions, residential solutions like ADSL or ADSL2+. Gray wires are the DSL supply coming in from our TA5000 shelf. And by the way, one TA5000 shelf is driving all of these NCTEs. So out of the gray wires, we come into these, we come out Ethernet, and then this Ethernet gets aggregated back into our core switches. You'll notice Cisco's are in here. We do a lot of interoperability with Cisco switches. But then we had talked about our traffic generators last. You'll see all of these go back to our traffic generators. So we're able to send traffic into the 5000, out to all of these simultaneously, aggregate it back to our traffic generators and analyze the data after it goes to the entire network.
And are there standard ways for doing traffic generation? I mean, like from the ITU or something like that, and the amount of traffic and different kinds of traffic that a certain solution should be able to support?
Sure. So, I mean, there's all kinds of different traffic types. We do a lot of 2544 Ethernet testing. That's just a standard set of tests that most vendors do. There's specifications for what they call, for example, iMix traffic, which is supposed to represent a realistic depiction of actual traffic on the internet. And then the most stressful traffic is 64-byte packets from a processor standpoint, because the processor in all of these units have to look at every packet coming in. So if you want to stress the unit, hit it with small packets. But the majority of the time, our customers are interested in something like iMix, which accurately represents real internet traffic.
And that way they can look at different vendor solutions and compare them on an apples to apples.
That's right. Yep, perfect.
Okay, Steve, now we're in another building at ADTRAN, and what happens here?
So this is our compliance lab, and this is Jeff Whitmire. He's the manager of the compliance lab, and this is another piece of our design qualification process, a very important piece. Most of the the work that Jeff does in this area revolves hardware, whereas the labs we came through a little while ago, most of the bugs we found were in software. So I'll let Jeff take it away here.
Okay, Jeff, show us the way.
All right, so the things that we generally do is take care of hazards or things that the equipment will see out in the field. So if we make a piece of equipment, we want to make sure it's going to work where the customer is going to deploy it. So we go through a series of tests. We also address product safety concerns. Product can't hurt anybody when they install it or other customers. So we do some various tests to cover that. One of the tests I want to show you in here is what we call our power fault conditions. When you think about telephones with copper wires going out through the world, sometimes AC power lines come in contact with those telephone lines. And so when that happens, AC power comes into a product and there can be some pretty dramatic effects. We work to design our products so that those things don't happen. We kind of want to demonstrate to you what would happen if you didn't design your product properly.
Okay, should be fun.
What we're going to simulate here is an AC power fault condition where AC power lines came in contact with the tips and the wires coming in from the telephone interface, and we will be running
about
30 amps through this circuit. Our circuit cards could see this kind of a fault in the field, so this is one of the things we want to evaluate for.
And what's happening right now?
Right now the machine is starting up and getting ready to generate drop the voltage and currents onto the wires going into the circuit board. The voltage is building up to 300 volts and he's ready to run.
That's not good.
No, that's not. That's what you want not to happen to the product. So we have design rules here at ADTRAN, and we go through a lot of evaluation of circuit cards and various things to make sure that doesn't happen on ADTRAN products.
Okay, thanks for the demo. This reminds me of a scene in Charlie and the Chocolate Factory in this room, but what really happens here?
What happens here is we have one of our design guidelines is we have to make sure our products don't interfere with radio communications or other equipment out in the field. People don't realize all this electronic equipment actually generates RF unintentionally. So we have a series of tests we do, and in this chamber we measure the RF emissions coming off of a product, and we make sure we pass the FCC requirements and we won't interfere with other products. The other thing we can do in this room when we wouldn't be in it would be to radiate RF onto the product so that make sure products work when somebody walks by with a two-way radio or a cell phone or something like that. We want to make sure our products are up and running all the time, and interference like that wouldn't shut them down.
And if if a problem is spotted, it would be interference, and then what do?
We have a pretty extensive series of design guidelines in this where we look at the printed circuit boards all the way down to the trace level, and we could move some traces on a circuit board and make the product compliant. So it's a very detailed kind of engineering environment where we look at the product from the printed circuit board all the way out to the finished product to make sure it would comply with these requirements.
Okay, thanks. So tell us about this tool on the screen.
Okay, we mentioned earlier that, if there is a failure, what do we do? One of the tools we have is a computer simulation software. We actually import the information about this printed circuit board. We do simulations on it to identify hotspots, which you would see in red, and that gives us a chance to simulate what we're seeing, try some fixes in simulations before we actually put it into the actual printed circuit board and make sure that it would comply after the fact.
So, Jeff, what is this gentleman in the plaid shirt doing?
He's simulating a static discharge test. So we've all felt ESD when we've gotten out of our car on a cold winter morning and grabbed the handle and zapped ourselves. Well, that happens a lot in the real world, and it could have some serious impact on the operation of the equipment. So we want to simulate static discharge onto the equipment. We have to build our equipment robust enough so that if a customer were to touch the product and discharge into it, there would be no impact on the service for the customers down the line on the telecommunication services.
So, Steve, there are different areas and different levels of testing and design qualification. Can you kind of run us through those and tell us what stage is happening here?
Sure. So this is actually design verification test. So this is the first stage of test that all the products at ADTRAN go through. We came through the PQ lab on the other side. That would have been the last stage of test that the products go through. This is Angela Nunley. She's the manager of this particular lab, which concentrates on our router and switch product line.
Can you tell us what's going on here?
So this is the design verification test lab for enterprise networks, internetworking part. So we do the NetVana routers and the switches. And this is the area that we test the code that is developed, and it's before that we go to the product qualification stage. So here we use several different methodologies of testing. We test a small scale setups on the bench to target specific features and platforms, as well as the large scale test beds where we try to scale the units up and emulate an actual customer network. We find that scaling the network to a higher volume of units accelerates our testing. It allows us to find more issues prior to the code reaching the field.
So it's not all theoretical. You're actually mirroring or doing a pre-install of what an actual customer's network will look like.
Exactly. In many cases where we have a large customer application that we're targeting, we get those customer requirements and then we try to build the network to look exactly like theirs. And we find that very effective in finding issues before the customer would reach the issues.
And again, I assume that would include a mix of ADTRAN's gear and whatever other gear the customer would have in their network and as their endpoint.
In some cases, the customer will actually provide us with the other gear that they're going to interface to, and we can test to that gear here in our lab. So this is one of our large-scale test beds that emulates, we have a VRRP network that emulates a customer that has redundancy in their network. And so we scale that up to accommodate many, many units.
And those are the NetVana routers?
Those are the NetVana routers and the switches. And over here we have a lot of our new switches, and this is a spanning tree test bed, so a spanning tree can be an evil thing that can cause problems. So we really like to do stress testing here on certain features that a customer is obviously going to have in their network.
Hi, Steve. I guess we're going to see a GPON demo here. Can you introduce the gentleman that's going to walk us through it?
Sure. This is Tommy Davis. He's one of the DBT engineers here, and this is the first phase of test, just like we saw in Angela's lab, except related to the ONTs.
Okay, tell us about it.
So this is our GPON fiber to the home solution that ADTRAN is rolling out, and a lot of the carriers are looking to bring to your home. This gives the ability to deliver triple play services. So your internet connectivity that you would traditionally get maybe over DSL, obviously phone, and now we bring in video to the telecoms to compete with the cable companies. And we've got two different setups. Our division is designed to test and design the ONT, and this is the portion that will actually be on the customer's home. Or we're making a small business unit so that businesses can also benefit from GPON or multiple PRIs, larger voice capacity than what you would experience at your home. So we test and develop these. This is one of our long-term test beds here where you can see we're actually running video services through the ONT. We have multiple different designs. They all look very, very similar, but in this case, it's RF that's coming in from our provider, but we can also support IPTV, Microsoft Media Room, some of the Minerva systems. Those are kind of competing IPTV-backed solutions. So other than, these are the smaller units, again, for the home. The small business unit is one we have here in our local test bed. Again, larger capacities for voice, T1 delivery to the premise. Also known as pseudo wire, and so we are working on that, and that should be coming out here this year. And we've got 5 different models out today. Probably going to add 6 to 10 more different models, and active Ethernet is another division we'll be working on soon. So we'll add a new blade and continue to test those. Very similar functionality, but again, this is more of the push for the telecoms to give fiber to the home.
I'm here with Chris Andrews at ADTRAN. Chris, what do you do in these labs, and what are you going to show us today?
All right, I'm the engineer manager over our design verification test group, otherwise known as DBT. And what we mainly do is we test weekly builds of our AOS voice code. We're primarily focused on the new features that are being developed for the current release, but we're also interested in regression test items as well. So we've got about 11 guys in our group. They're mixed with certified engineers with degrees with CCNA, CCNP credentials, and also we've got some folks that are focused on automation. So primarily we gear toward, like I said, the new features, but we do have an automation team as well. And what I'd like to do right now is just kind of walk you through what a typical code release week looks like, and maybe a flow of how the code would make it through our group and then on to other groups that test the code after we do.
Sounds good.
So the first thing we do, we get the AOS weekly release, and we can handle several of these a week, but primarily we'll get that on a Tuesday or a Thursday. So one of the first things we do is we run it through our smoke test bed, and we've got a manual smoke test bed, and we also have an automated smoke test bed that tests a lot of different features, those basic call functionality, ring back, conferencing, transfers, those type of things, to make sure all that foundational items are still working. Once it goes through there, if everything works well, then we start hitting some of our automated test beds, and we try to run these every week. Some weeks we'll skip a week, but primarily once the code starts getting into this area, it will typically stay there for a while. So we try to run through that. Once we're satisfied with the performance there, then we're able to go on to the next level of our testing, which is some of our long-term testing. We have our customer readiness test bed, which takes about a day and a half to run it, and DSP testing and fax lab testing. So anyway, once we get through all those, then we're able to go to some of the other groups. Once the code, this is getting pretty late in the cycle, and then once we're there, we're kind of ready to shoot it out the door for customers. I'd also like to show you guys our phone wall, and I'm going to kick this off. This is some of our automation test software, and I'm going to go ahead and kick this off, and while this starts running, we're going to walk around over here to the phone wall, and I'm going to kind of show you some of that stuff.
Sounds great. So here we are at the wall of phones.
This is the wall of phones. There's phones on both sides. There's 100 phones here. Our NetBand is 7100. We claim we support 100 users. So this test bed actually proves that we can have 100 phones on there. Basically, the test that I'm running on these phones now will start cycling through the phones. It'll start powering the phones on and off. They'll start hitting the 7100, pulling config files, pulling new software, registering, and being ready to make calls. The test setup that I've got runs through several iterations of that. Then once it's through, it will check to make sure all the phones came up, got the right firmware, and registered and are ready to make calls.
Great.
So as we're watching that, you'll start seeing the phones cycle on and off. We're probably getting very close to that starting. But anyway, we always want to try to test out the applications here in the lab, and we'll try to run this test at least once every 2 weeks.
Great. Well, thank you very much, Chris. And this is Paula Bernier for TMC signing off.